Good morning, Internet! Actually, many of you probably don't get that reference anymore, so let me start over. Welcome to Physics with Joe. Today we're going to look at how do you calculate the magnitude and direction of a vector given its x and y components. In a previous video, I talked about given the magnitude and direction, how do you calculate the x and y components? Today we're doing the reverse. If I already have the x and y components of a vector, how do I get the magnitude and direction? And the simple answer is Pythagorean theorem and inverse tangent.
That was easy.
Well, that's it for today. Tune in next week when we'll be talking about something else fascinating. Oh, you're still here? You need more information about calculating the magnitude and direction than just Pythagorean theorem and inverse tangent? Well, since we're both here, we might as well learn together. So let's do it. In a previous video, I talked about how to calculate the x and y components of a vector if I know the vector's magnitude and direction. If you haven't watched that video yet, I highly recommend you watch it before continuing with this one. I'll put a link in the description below. Now we're going to look at if I have the x and y components of a vector, how do I get the vector's magnitude and direction? Hopefully you remember that for a vector, its x and y components form a right triangle with the vector, which means that I can relate the lengths of the sides using Pythagorean theorem, and I can relate the angles to the lengths of the sides using SOHCAHTOA. If you take a look at this force vector over here, what you'll see is that I've got a right triangle, the x and y components of the force are the legs of the triangle, and the magnitude of the force is the hypotenuse. Also notice that for that angle theta, the y component is the opposite side, the x component is the adjacent side. So from Pythagorean theorem, the magnitude of the force squared equals the x component squared plus the y component squared. Or, if I want to know the magnitude, it's just the square root of the x component squared plus the y component squared. This will always be true for any two-dimensional vector. Now, we're not going to talk about vectors that also have a z component, but for two components, two dimensions, the magnitude is always the square root of the x component squared plus the y component squared. In terms of the angle, I have the opposite side, which is the y component. I have the adjacent side, which is the x component. So the tangent of theta should be the y component divided by the x component. Or if I want the angle itself, I can take the inverse tangent of each side. And what I get is theta is going to be the inverse tangent of the y component divided by the x component. You can always use this equation with one caveat. That caveat is, if you use inverse tangent on your calculator to get the angle, your calculator will only ever give you an angle in the first or fourth quadrant. If you know that vector should be pointing in the second or third quadrant, you're going to have to add 180 degrees to the answer. How are you going to know if that vector should be in the second or third quadrant? Well, that's going to depend upon the sign of the x and y components, and I'll talk about that in a second. Now that we know how to calculate the magnitude and direction of a vector from the x and y components, let's take a look at a couple of examples together. For these two vectors, let's assume that they are position vectors rather than force vectors. Position is a vector that describes how far an object is from the origin and in what direction. The units of position are meters. Let's first take a look at A. So A is a position vector, and you can see the x component of A is 22 meters. The y component of A is 8 meters, which means whatever object this position vector would be referring to is 22 meters to the right of the origin, 8 meters above the origin. What we want to know is what are the magnitude and direction of this position vector. Well, magnitude super easy. We just use Pythagorean theorem, the square root of the x component squared plus the y component squared. In this case, if I want the magnitude, I take the square root of 22 meters squared plus 8 meters squared, and what I get is 23.4 meters. If I want to know what is the direction of this position vector, or what is the angle, I'm going to take the inverse tangent of the y component divided by the x component. In this case, we have my y component is 8 meters, x component is 22 meters. I take the inverse tangent of 8 divided by 22, and what we get is 20 meters. So this particular position vector, my magnitude is 23.4 meters, my angle is 20 degrees.
That was easy.
Let's take a look at a slightly more challenging example. Still fairly straightforward with one small caveat. Vector B, again, we'll assume it's a position vector. It has an x component of negative 10 meters, a y component of negative 10 meters also. In this case, what that means is whatever object this position vector was referring to is 10 meters to the left of the origin, 10 meters below the origin. If we want to know what is the magnitude, again, very straightforward, square root of the x component squared plus the y component squared. If you take the square root of negative 10 meters squared plus negative 10 meters squared, what you get is 14.1 meters. Easy peasy. Now let's calculate the angle. Remember, we can always use inverse tangent of the y component divided by the x component. In this case, the y component is negative 10 meters, the x component is negative 10 meters. If you plug into your calculator the inverse tangent of negative 10 divided by negative 10, what you're going to get is 45 degrees. Notice, that is not the correct angle because 45 degrees is in the first quadrant. This particular vector is in the third quadrant. Well, anytime you use your calculator to calculate the inverse tangent of an angle, if that angle should be in the second or third quadrant, your calculator will give you an answer which is off by 180 degrees. Now, how are you going to know if the angle should be in the second or third quadrant? Here's a nice, easy shortcut for you. If the x component is negative, you know that vector's either going to be in the second quadrant or the third quadrant. If the y component's positive, you know it's going to be in the second quadrant. If the y component's negative, you know it's going to be in the third quadrant. But anytime the x component is negative, your calculator will give you an answer which is 180 degrees off, and you need to add 180 to whatever the calculator gives you. In this particular case, we took the inverse tangent of negative 10 divided by negative 10. The calculator gave us an answer of 45 degrees. That is incorrect, so you add 180 degrees to that. The correct angle is 225 degrees, and that's the direction relative to the positive x-axis. Let's just do a quick 1-minute recap of how to calculate the magnitude and direction of a vector given its x and y components. Calculating the magnitude, super straightforward, Pythagorean theorem. The magnitude of any vector equals the square root of the x component squared plus the y component squared. Now in calculating the angle, we're always going to use the inverse tangent of the y component divided by the x component with one caveat. If you know that the angle should be in the second or third quadrant, you have to add 180 degrees to the answer your calculator gives you. It will only give you an inverse tangent angle, which is in the first or fourth quadrant. How are you going to know if the angle should be in the second or third quadrant? Super easy. If the x component is negative, then you know that particular vector is either in the second or third quadrant. That's really all there is. Thank you so much for joining me. My name is Dr. Joe McCullough, and I look forward to seeing you next time. I need a catchphrase.